live TypeScript notebook that supports rendering front-end DOM elements. And so you can make your own custom live visualizations for your code. And I think I'm going to run this off of my computer just for make sure the internet works, right?
Yeah, thanks. I'll be there for the Q&A afterwards, though.
Yeah, all right, so let me get that going.
Hi, I'm Yousef El-Dardiry, a programmer from the Netherlands, and I believe programming can and should be made way more simple. This year, I went on a journey to explore how I would build my ideal live notebook environment. Of course, in this work, I've been inspired by a lot of previous work, ranging from Brad Victor's incredible demos and presentations to many of the topics people like you in the programming research community are working on. So it's great to be here. As a software engineer, I've been excited by the rise in easy-to-use online programming environments like CodePen, Codespaces, Glitch, etc. It's never been easier to open an IDE to explore, modify, and share changes to a software project. However, even though they have taken away some barriers to editing and running programs, these environments focus on traditional software development and miss quite a few of the benefits of live programmable systems. Then on the other hand, you have notebook environments such as Jupyter and Observable, and they really reimagine what programming could look like by providing a lot of immediate and live feedback. This then has a lot of benefits, but as a web developer, I'm missing a number of features from my traditional development environment. This is why I started building TypeCell notebooks. TypeCell notebooks is a new notebook-style live programming environment with a focus on first-class support for the modern web ecosystem, like native TypeScript support, NPM packages, React, and JSX support. It builds on top of the same high-quality editor that you know from VS Code, Monaco. What's also important is that I plan to open source TypeCell notebooks later this year. So I'm really excited to see what the community can build on top of it. All right, enough said. Let's explore what TypeCell looks like. I'll first focus on the basics, and later on I will explore some of the more advanced capabilities and possible directions for future work. All right, so here we have a basic TypeScript cell in the TypeCell environment. We assigned a string to a variable, but we don't see any output yet. We use the export keyword, and then any exported variables are displayed as output of the cell. As you can see, the string, the output updates automatically based on the code that I've entered. Now, what we can do is now we have this variable here. We can start creating a new code cell, and we can reuse exported variables from other cells. So if we say, okay, export number of characters equals, then we use the $, and under the $, we get code completion for the exported cells. So we'll say, okay, message.length is the number of characters, and I'm missing a number of characters is not defined, so I get an immediate error because I was missing the let JavaScript statement. Here we go. TypeCell cells re-evaluate when the code changes or when any of the dependent variables changes. So now if I update this, you will see also the number of characters is recalculated and updated. Now, instead of just exporting a number or a string, we can also export HTML elements or React JSX. So what does that look like? We can create a div, and a div here, and then with React style code. Strong message. So we now format a nicer output message, and of course this also updates. The way this works is that exported variables are automatically turned into observable variables. And through this reactive engine that runs through the notebook, we update everything automatically. So let's see what a little bit of a more advanced example looks like. So in this example, we use a text area to gather user input, and then we calculate the character counts with a simple code using the Lodash library, which is imported from NPM. So as soon as I type here, you also see the numbers below updating. We can take this one level further by importing a charting library, so in this case React Vega, and instantly see the character counts. So this really shows the power of instantly evaluate as you type environment. Is that as soon as I type here, let me add some cues, for example, the chart automatically updates. And the cool thing about it is it's pretty much regular TypeScript. So I don't need to use any extra language constructs or a lot of framework plumbing, as I'd like to call it, to get this reactive behavior. This is all built into the notebook system. Before I dive into some more advanced examples, I want to discuss some of the challenges in creating this programming environment. So there's a couple of challenges that I encountered because you're executing user code in the browser on the client directly. First of all, a user can create infinite loops. The programming model with the reactive variables, I think, can be very powerful, but I still want to explore whether it's intuitive enough or whether we can go one level further. Then if a user calls set interval or set timeout or registers some kind of event handler, you need to figure out a way to dispose those resources in the user code. I think we came up with a way to do that for most scenarios. And the one that I want to discuss more deeply now is security. So how do we actually execute user code without causing any possible security issues? The way we've solved this is by executing the JavaScript code that the user creates in a separate iframe that runs on a different domain than the main application. So the user can't create code that, for example, wants to grab the cookies of the TypeCell website or the authentication details, etc. So this is the basic overall architecture. So the user enters its code in the editor. The TypeScript code is being sent to the compiler, and then the compiler, of course, compiles the TypeScript code to JavaScript, and then via post message, it's being called to the JavaScript code is being sent to the sandboxed iframe, which then evaluates the code either when the iframe has received a new code update or when any of the reactive variables used in that code have been updated. And that part is powered by MobX. Now that we have the basic functionality of TypeCell notebooks, we can see whether we can extend the notebook environment with features that can help ease of development for the end user. Something I've played around with is building custom visualizers and inspectors. Let's have a look at that. In this example, you see three variables. The first one is a string, the second cell exports a color, and the third one a location with a latitude and a longitude. We can now use the type system to help the developer in displaying these different type of variables. So we can do this by creating a type visualizer. Here we take one that takes a string as an argument, and it returns the value that it was passed in uppercase. Now that we've defined the visualizer, it is now selectable in the cell that exports a string. So if I select uppercase, it will show it uppercased. We can make different visualizers for different types. So let's create one for the type color, which is defined by a red, a green, and a blue attribute. Now, first, what we do for a nicer effect is we assign a different color, we increment the red channel using set interval. And then here, we can create a type visualizer, which takes an RGB type variable and then renders a small React box with these different colors. As you can see, it's now selectable in the cell with the color. And as expected, we now have a different way of visualizing the value of color. We can go even more advanced and create one that exposes a map. So now if we export a variable with a latitude and longitude, we have the map here available that is defined here. Of course, if I would change this into something else, it wouldn't be available, but now the system recognizes it's a location, and I can use the map visualizer, which embeds a Google map of the passed-in location. And I could also change this location, and the map would update automatically. Another direction that I found very interesting to explore is what would happen if we break out of the notebook environment, and if we bring the live system of TypeCell as a first-class citizen to a different application. I've explored this idea by embedding the TypeCell engine inside a block-based document editor. In this little animation, you see how I've used TypeCell code to define a new element, which is a scrubber, as popularized by Brad Victor in his Reactive Documents and Explorable Explanations. And that scrubber can then be used inside the document and reused to manipulate the appearance of other blocks. All right. Thanks for your attention. Looking forward to any questions, and also in general to all your to any feedback that you might have. So I've put up a little bit of a placeholder website where you can sign up for the preview, check out more demo videos, or you can drop me an email, and I'll keep you posted on any future developments, including when I plan to open source TypeCell.
All right, thank you.
All right, thanks.
All right, thank you, Yousef. And we have time for a few questions. You can either ask your questions on Zoom or, raise your hand on Zoom, or you can ask in the Discord. We have a question in the room here.
Hey, Yousef, thanks so much for this presentation. TypeCell looks very exciting.
I am continuing by expanding insert.
We got a little cross audio. Can you build a full React components within TypeCell? And if so, how does TypeCell's reactive engine work with React's approach to reactivity?
Yeah, you can. So I think those are two separate things. So on one hand, the demo that I showed mostly see the use of JSX and TSX, which doesn't completely rely on the React components. It's just a way of a nicer way of writing a typed HTML. But you're definitely also able to use or create React components. It's just JavaScript or TypeScript that evaluates as JavaScript. So that works as well. I think, but this is a personal preference of mine. I think sometimes the state management in React is a little bit cumbersome. So I also like my state and stores to be reactive. So prefer more like a MobX observable style interface, which is of course natively supported in if you use variables from other cells, that's natively supported. But just using useState should work as well.
Thank you.
It looks like we have a question on Discord. Camille asks, is there some kind of reflection API that would enable us to modify the code that is being visualized? For example, a color picker that updates the RGB values in the code in addition to displaying the color they represent? Or is that something you've considered? So give a little bit of bidirectionality to the system.
I was thinking of this actually right now when I rewatched my presentation. So thanks for the question. So there's currently not an API with which you can change the code. I do want to build something like that later. But what is already there is that the way the variables are set up, it's a two-way system. So maybe you remember the how we change the red channel every millisecond, which means that from another piece of code, it's possible to assign or override an existing variable. So what we could do is create a button inside the type visualizer. I'm pretty sure that helps, that works already, where you indeed change the original value. So that would work, but you can't yet edit the code of the original cell.
All right, thanks. Jess has a question.
Yeah, Yousef, I love these notebook environments, but one of the things that I always wonder about is what's the how might you think about like building an application in a live notebook environment and then kind of putting it in production or like using it outside of, so what's the story kind of from working with a TypeCell notebook to taking the output of that notebook and making that more publicly accessible? Have you thought about that much?
Yeah, thanks, Jess. I love the question. I've experimented with that, still early days, but actually there's one application running for some sort of a friend of mine. And what I would like is very close integration with normal development environments or tools such as GitHub. And that's nice because currently the code that is being written in a notebook, it's possible to export it as a Git repository, and it's all just regular TypeScript. So there's no custom language construct. So you can actually export the notebook as a program, which is pretty much an NPM website with one or two extra libraries. So I would love for that flow to be as easy as possible, so you can really publish your website from what you've built.
That's cool. That's awesome.
So it looks like last question here from Cyrus. How does TypeCell handle external side effects? So you probably don't want to be making network requests on every single keystroke or database writes on every single keystroke. So is there a story about that?
That has not been covered yet. So I think a network request should be canceled automatically. Database request is not integrated yet. So this is something I think that should be explored. So a simple option would be like a debounce. But so far, I haven't ran into too many issues with the as you type execution. And this is, I think the real answer here is I'd love to see how people enjoy the feedback as you type and whether, yeah, what kind of issues like these come up. So that's going to need some real world testing.
Right. Actually, we might have time for another question. We have to do a little bit of setup here for the next talk.
Cool.
So
Thanks. Any final questions?
I have one more. Yousef, have you thought about turning this into a collaborative environment as well?
Yeah, so thanks. The engine below is actually, I think it's been discussed a couple of times today. So it's built on the editors and all the data structures below it are using a CRDT. YJS, which is really built for these collaborative use cases. So there's this whole that should be first class, and I actually also wanted to be able to work offline. So I'm really inspired also by I think I mentioned it on one of the first slides, the local first essay by Ink and Switch. I think that kind of nails like, okay, how applications should be written. So this is also an area where I'm exploring that.
Awesome. Look forward to it.
Thanks.
All right, let's thank Yousef once again and give us a few seconds here in the room to get the next talk ready.
Thanks all.